Alright, let's start with numerical solution of equations. So basically, let's suppose if we have a quadratic equation. Okay? We have several ways of doing it. We can solve it algebraically, which is using the quadratic formula. We can solve it graphically, that is, we draw the graph first and then we find out the solutions. Okay? And the third way of solving any kind of equation which cannot be solved algebraically is numerically. The method that we are going to do in numerical solution of equations is the iteration method. Okay? There are a lot of techniques of solving anything numerically, but we are only going to focus on one of them, which is iteration. Okay? Now, what is meant by when I say solutions? Solutions means x-intercepts, or the also known as the roots of the equation. Okay? Or intersection points. Solutions are always values of x. Make sense? Okay. When I say roots, this is my root. If I take a value of x before the root, that gives me a positive value of y. And if I take a value of x after the root, that will give me a negative value of y. So if y changes from plus to minus, can I say the root lies somewhere in between because it must be crossing the x-axis? So if y goes from plus y to a minus y, it means the root is somewhere in between. Right, Hassan? Sarah, it will take some time.
Yes, I'm confused in the third part.
Do as much as you can
Yes,
on
I'm
your
done.
own. Then start with the exercise.
Okay.
This question. Leave these. If this is the graph and this is the root, if I take the value prior to the root, negative y, if I take a value of x after the root, positive y. So if y goes from minus y to plus y, can I again say that the root lies in between? Now, we need to understand what is iterative formula. What is iterative method? Iteration means if this is my equation, we make one of the axes x the subject. Let's suppose this is the x that I made the subject. Yeah. No. Make sense? We will start with the value of x as 0.25 and we'll plug it in here. The value of x that I will get as an answer will be plugged in again in the same formula. We plug the new answer, again plugged in the formula. The process is repeated
until the same number.
Until you get the same number, until you get a constant value. Now, what are the expectations from this chapter according to the syllabus? Let's do it with the help of an example. The first question generally relates to proving the equation, and then they will move on to verification of the root and then applying the iterative formula. Does it make sense, Hassan? Okay. So the question here says, given that the sum of areas of the shaded region is 90% of the area of the trapezium, area of sectors is going to be half r square, theta is x here, multiplied by 2, so it's r square x. Now for the trapezium, this entire length is 2r, but we don't know the height of the trapezium. Can you find it out? With respect to this is opposite and this is adjacent opposite length will become r sine x. Adjacent length will become r cos x. Make sense, Hassan? This one is r cos x. This is also r cos x, the blue region. 2r minus 2r cos x will give me the length of DC, right? Which is this length. So this is DC. Make sense? This is height of the trapezium, right? Now, area of trapezium will be half into height into sum of parallel sides. One side is 2r plus 2r minus 2r cos x. Does it make sense? Okay, now here, r sine x it will become, I can take 2 and r common out. Right, Hassan?
Hassan's father is calling him. Apparently, his drivers come.
Cool. क्या हो गया?
मैं शायद दूसरा कंप्यूटर साइंस.
Okay, so some of the areas of the shaded regions is 90%. Okay, this is the shaded region. This is 90% of there will be no R here now. This is what they want you to prove. Does it make sense?
Yeah.
Yes?
Yeah.
Verify by calculation. The root lies between 0.5 and 0.7. We said that the root, what is the root? X-intercept. And for x-intercept, you know the entire equation should be equal to 0, right? So this is the equation, we'll put it equal to 0. We will first input the first value of x, which is 0.5, and then the next value of x, which is 0.7. If the y value changes from plus to minus, we know that the root lies between these two values. How to go about it? Plug it in the equation. हो गया sin x 2 minus cos x minus x. I'm getting a minus 0.492. And when I calculate 0.7, I'm getting a minus, no, there's something degree mode with her. With 0.7, I'm getting a 0.0161. And with x 0.5, I'm getting a minus 0.0157. Change of sign indicates that the root lies between 0.5 and 0.7. Writing this statement is very important. This entire thing is also very important. So this is a very important concept of verification of root that is often asked. Does it make sense? Let's look at this third part of this question. Over here they're saying show that if a sequence of values in the interval given by the iterative formula converges, then it converges to the root of the equation in part A. Now there are two things to it. This is the original equation that we formed in the first part, and then from that we form an iterative formula through which we can find out the answer. So this is the iterative formula where they have made this x the subject. समझ आ रही है बात? Now what they want you to do is go from this iterative formula back to the original equation and show that this iterative formula goes back to its original equation. The moment whenever they use these words, show that if a sequence of values converges, then it converges to the, it means we have to show that the iterative formula goes back to the original equation. They can also ask you to go from original equation and make the iterative formula. They can give you the formula, but they can ask you to show it that you are also getting the same thing. Now, iterative formula has these subscripts which you don't need to write when you have to prove something. We need the subscripts to find the answers only, okay? Let's take cos x let's take the LCM. I'll take 0.9 and sin x common out, and also take a minus sign common out. This was the original equation that we formed in part A. Proven. Does it make sense, Hasan Shekhar?
Yeah.
Clear? Okay. Use this iterative formula to determine x correct to. Now, how to use the iterative formula? That's the question. My iterative formula is cos inverse 2 minus x upon 0.9 sin x. You know that the root lies between 0.5 and 0.7. You can take any value as the first value of x. Can I take the first value of x as 0.5? Save it in the calculator as an answer. Okay?
Okay.
0.5 would be saved as an answer first. Here, look at the calculator. Right? Okay. Now, how do we proceed? We will now put the calculator equation in the calculator like cos inverse 2 minus answer divided by 0.9 sin answer. So it will keep using the recent answers and give you the next answers for it. So cos inverse 2 minus answer divided by 0.9 sin answer, and press equal to. The second iteration is 0.5713.
And then press equal to again.
Third is 0.5987. 0.61.
So once it starts repeating, we stop.
Yes. X5 is 0.6148. 0.6169. 6178. 6181. 6183, 84, 84, then again 84.
Okay.
So I can say that it converges to 0.618. This is the answer correct to 3 decimal places.
Okay.
Clear about it?
Is
Any
it
problem
standard
here?
sheet decimal place?
The question always mentions okay, they want the answer to 3 decimal places or to 2 decimal places. Clear about it? This is almost everything covered in iteration.